Okay guys, today we're going to try to kind of put some things together here and use the elimination method, but we're going to use it in some more wordy type problems, okay? And I'll try to walk you through these because I know some people have trouble converting the words to a working equation. A lot of times people don't have trouble doing the algebra. It's the getting the words into a working equation or set of equations that people have trouble with. So let's try this first one here. They said the sum of two numbers is 361. So let's break this down. All right, and let me just underline the sum of two numbers is 361 because that's going to be one of our equations. Oh, that's a terrible one. Let's see. That's going to be one of our equations here. So I'm going to put a 1 up there, and we're going to underline that, okay? And it says also, and the difference between the two numbers is 173, and that's going to be our other equation, all right? And you see they're doing two different things here. One is taking a sum, and the other one is taking the difference, all right? So one is adding, and one is subtracting, all right? So let's try to come up with the equations. Now, if this is a word problem, then the first thing I want to do is define my variables, and they tell me that I'm dealing with two numbers. And they didn't tell me anything about those numbers, like if one is double the other or one is 4 less than the other. So they really told me nothing about those two numbers. So I'm going to have to define them with different variables. Okay, so I'm going to say let x equal one number, and the y is going to be the other number. All right, this is going to be another number. So I'm going to use x and y to stand for my two numbers. And now let's try to come up with some equations that will work here. All right. The first one says the sum of the two numbers. So that's pretty easy. I'm just going to take x plus y. And that sum is going to be equal to 361. All right. So that I used this section right here. The sum of the two numbers is equal to 361. Okay. So that's pretty easy. Alright, now let's go to this other section. It says the difference between the two numbers. Well, that would just be x minus y. Alright, the difference of the two numbers is 173. Okay, well those were pretty easy to come up with. Now I want to be able to solve them. Alright, and I'm going to use the elimination method. Since I have two equations and two unknowns, I can use the elimination method. And should I add these or should I subtract these? Well, if I add them together, the 1x and 1x are going to give me 2x. The plus 1y and minus 1y, well, those will give me 0. So that's a good thing. I'm just going to add these two. Notice how I still put my parentheses here, and I put my plus there. It's just going to make it so much easier for me to visualize if I do that. All right. So 1x and 1x is 2x. 1y plus negative y, well, that gives me a 0y. Alright, and 361 and 173, that gives me 534. Alright, so my whole equation, this 0y, here's my elimination, right? That 0y is eliminated. So I get 2x equal 534. Alright, and then now I have one equation and one unknown, so that's good. I can just divide by 2 on both sides, and x equals, what is that going to be? 100, 200, 262, 262, no, it's not going to be 262, it's going to be 267, yes, alright, so 267, now I didn't answer my question completely, I've got this one, right, that's going to be 267, I've got to figure out what y is. So we do the same thing we did in the previous sections here. We take the x and we plug it in for one of these original equations. So I'll just take this one. I'll take this top one here, and we'll switch over so that we're in red, and we'll say, here's the equation. Well, I just got 267 to be equal to x. So I'm going to plug that in right there. Alright, so that means 267 plus y equals 361. And again, I have one equation, one unknown. I can just subtract. by 267 on both sides. And those go away, so y equals, let's see, what is that going to be? That's going to be 94, I believe. 94, yeah. So my other answer for y is, whoops, 94. Okay, so I've answered my two numbers here, are 267 and 94. I've answered my question here. All right. So there's an example of how we can use elimination method to solve a more wordy type problem. So let me turn that off. Alright, here's exercise 2, and this one is a little different. We're talking about number of boys and number of girls at Bobcat Middle School. It says there are 356 8th grade students at Bobcat Middle School. There are 34 more than 4 times the number of girls is equal to half the number of boys. They want to know how many boys and how many girls are there. Okay, so this is a classic, mathematical problem that you can work out using elimination method. All right, so let's give this a shot. All right, let's write down what they're looking for first. Now it says how many boys and how many girls are there in the school. So let's say let x equal the number of girls. Okay, and let's say y equals the number of boys. Okay, and so that really gets rid of all of this. We don't have to look at this again. We know what we're trying to find here. Alright, so let's see if we can come up with the two equations here. I'm going to section that off so I don't take up too much space here. But there are 356 8th grade students. Well, that tells me if I take the number of girls and add the number of boys, I get 356. Okay, well there's one equation. So really I've used that. Alright, now this is the more difficult one to come up with. So we'll take this one a little slower. 34 more than 4 times the number of girls. Let's just do that part right there. Let's do that part in blue. Okay, 34 more than 4 times the number of girls. Well, 4 times the number of girls would be 4x. The number of girls is x. And if I want 34 more than that, well, then I just add 34. Okay, well, that wasn't too bad. That takes out this part of the words. Then I run into is equal. Well, that would tell me to put an equal sign. All right, and it's equal to what? It's equal to half the number of boys. Well, when I half something, I multiply by a half, and the number of boys is y. All right, so there's my two equations that I'm going to use to figure out how many girls and how many boys. All right, so if we're going to do elimination method, now remember, elimination method, you want your x's and your y's to line up, right? Well, right now they don't. So I'm going to go down here, because I don't want to muck up all of this area up here. I'm going to go down here, and I'm going to change these equations. It's going to be equivalent, or just this equation. I'm going to change this equation so that my x's and my y's and my number, they're going to line up with this top equation here. Right? So I'm going to move this y term over to the left side of the equation. I'm going to move the 34 over to the right side of the equation. So let's take away 34 on both sides. So I get 4x equals 1/2 y minus 34. Okay, they go away there, and I get what I have on the right side. So then I need to move this y, I need to move it to the other side of the equation. So let's do that by subtracting. So my new equation, which is really equivalent to my other one, to the one that I started with, is going to be that. And don't forget your negative here. See this negative right here? That's important. That'll really change your answer if you don't bring that down. So I'm going to bring this equation here, and I'm going to send it up, and we're going to rewrite both of these. This top one doesn't change at all. This top one is still going to be x plus y equals 356. Alright, this bottom equation is going to be different looking, although it's still really the same equation. Alright, you're going to have this equals negative 34. Alright, so now we're set to do the elimination method. Now we're set to try to get rid of one of these variables. Now I think the easiest thing to do here is to simply multiply the top equation by 4. Okay, so I'm going to write this in, and I'm going to put a 4 right there, meaning I'm going to distribute this 4 to each one of these terms. Some people may do it a different way. Some people may say, well, I'm going to multiply through by a half, and that's going to get rid of this y, but that would only introduce a half here, so I'm really not going to get rid of the fractions at all or anything. But, you know, to each his own. Alright, so I'm going to draw a little dotted line here so that my equations don't get mixed up. So I'm going to draw my result from distributing by 4. I'm going to put that right down here. So 4x plus 4y equals, now what is 4 times 356? Let's put out the calculator here and let's multiply by 4. I get 1424. Okay, so 1424 goes here. And I'm going to draw this line just so you don't get confused by this arrow. It really doesn't mean anything. Okay, so there is my new equation from distributing the 4. And I can copy down my second equation here. That's not going to change. That's going to be right here. Minus 1/2 y equals negative 34. Okay, and I'm going to subtract these two equations. So let me put my subtraction sign in. And I'm going to take 4x minus 4x and I'm going to get 0x. That's going to be my new equation down here. 4y minus a negative half, well, that is really going to be addition, so that's going to be 4.5y. And if I take 1424 and again I subtract a negative 34, that's really 1424 plus a 34. So what am I going to get there? I'm going to get 1458. Alright, so really it boils down to, since this is elimination, that is eliminating right there. It's 4.5 y equals 1458. Alright, and then we're going to divide by 4.5 on both sides. And I'll bring my answer right up here. Y equals, and let's get out the calculator and divide here, 1458, and I'm going to divide by 4.5. So that equals, 324. That's nice. Good thing we didn't have 0.5 of a person or 0.8 of a person. That's always not a good thing. Okay, so the number of boys that we have is 324. And how are we going to figure out the number of girls? Well, we're going to do our substitution. We're going to take the top equation. That looks like the easier one to deal with. 56. And I'm going to plug in this y. I'm going to plug it in right there. Okay, so x equals, whoops, not equals, x plus 324 equals 356. Okay, and I'm going to take away 324 from both sides. And what are we going to get here? We're going to get an x over here. And if I subtract those two, let's see, that's going to be 32. So I have 324 boys and 32 girls. Now that's quite a difference. Alright, I'm going to take my calculator here and just check that really quick. If I were to plug those into one of these equations, and I'm more curious to see how it works in this bottom equation. So if I take 4 and I multiply it by x, that's 32. Alright, I get 128. And then I add 34 to that. That side of the equation, that's going to be 162. I'm going to write that right up here, 162. And if I were to take half of 324, so that'd be 0.2 times 324, that also gets to be 162. So it looks like that is quite a difference in girls and boys, but it does work out. It does follow this equation and provide a solution for that. Okay? Alright, one more to go. Let's look at number 3. Turn this off. Alright, Jimmy John Jameson has some bills in his wallet. They are either $5 bills or $1 bills. Altogether, he has 18 bills and a total of $62. Okay, so what we don't know is how many of each bill does she have. Alright, is that a she? Boy, that should be a he, shouldn't it? Jimmy John Jameson. No, that's a he. Alright, so it should say how many bills does he have. So anyway, what we don't know is the number of $1 bills, okay, and that is not money, that is the number of bills. And the other thing we don't know is the number of $5 bills. Okay, and we'll put the word bills up here so we're all on the same page here. So I have used this part right here. They are either $5 bills or $1 bills. And this part really isn't important. He has some bills in his wallet. So really it all boils down to this right here. This is going to give us 2 equations. Surprisingly enough, that's going to give us 2 equations because it says all together. Well, usually when you take all together, you add things, right? You add items together. So all together he has 18 bills. So the number of $1 bills and $5 bills, if I add those together, I get 18. Alright? The other equation is going to be right here. He has a total of $62. Notice that is dollars. Alright? Now here's the part where people they have a little trouble seeing at first, but once you see it, it should be pretty easy. If I have the number of $1 bills, well, if I take that number of $1 bills and I multiply by 1, that would be money. Okay, so this X right here is representing money. Alright, and if I have the number of $5 bills and I multiply by 5, that is again going to be how much in money he has. So he has this much in money in $1 bills. He has this much in money in $5 bills. Well, if I had money and money, I should get money, which is right here. That's $62. That's a tough thing for some people to see. Alright, so make sure you get that. Up here in the top equation, this is just number of bills. Alright? Down here in the bottom equation, this is money. This is how much money he has in $1 bills. This is how much money he has in $5 bills. And again, this is $62 total. Alright, so there's your equation. And we want to do elimination method. Well, look, this X, both of these X's, both have a 1. We could simply subtract these two. So I'm going to put my parentheses. I'm going to subtract. 1x minus 1x gives me 0x. 1y minus 5y gives me negative 4y. And 18 minus 62, that's also going to give me a negative. What is that going to be? A negative 44. Okay? So the equation boils down to negative 4y equals negative 44, because there's your elimination. And then I simply divide by negative 4 on both sides, and y equals 11. So the number of bills, the number of $5 bills, that's y, the number of $5 bills is 11. Okay? So now I take one of my equations up here. Let's use this one, because this one seems pretty easy. I don't have any numbers in front of the variables. I don't have any coefficients up there. I take my 11 and I plug it in for y, and I solve, and I get a 7. Alright, so the number of $1 bills is 7. Let's see if that would really work. If I have 7 $1 bills, that would be $7, right? If I have 5 $1 bills, that would be $55. If I add those together, that would be $62, and that is what our equation right down here says. That should be true. And if I add them together, 7 plus 11, I get 18, and that's what our equation right there says. Alright, so there's number 3. Okay guys, here is exercise 4, and this is about Sarah Sue Sampson. This is a little different in that they give us the number of boxes of pencils and number of notebooks she bought one day. Altogether, this cost her $11. She went back the next day and she bought 3 boxes of pencils and 5 notebooks. This cost her $11.25. What we don't know is how much did the box of pencils and each box of notebooks cost. So that is our variable, or our 2 variables. Okay, so I'm going to put that up here. I'm going to say let x equal the cost of each box of pencils, I should say, box of pencils. Okay, and the other item we don't know are the notebooks. This is going to be the cost of each notebook. So there's my x and my y. There's the things I don't know. Now let's use the information they gave us to create some equations here. So 2 boxes of pencils and 8 notebooks. And they're giving us what this all together comes to. Notice they're giving us money. So I simply can't say x plus y, because that would be the number of boxes of pencils and the number of notebooks. I want the amount that those cost. So 2 boxes of pencils, so that would be 2x. That would represent the money that is represented by 2 boxes of pencils. And I'm going to add with that 8 times y. That's 8 notebooks times the cost of each. Again, that's how much, that's the cost, that's the dollar amount of 8 notebooks. And we said when she did that, that all came to $11. Alright, so again, money plus money should equal money. Alright, so really we've used this part of the word problem up there. Okay, the next day she went back to the same store. She bought 3 boxes of pencils. Okay, so that's going to be 3 boxes of pencils. And that is how much money it cost her. 3 times the number of, or the cost of each box. And she bought, how many notebooks? She bought 5 notebooks. So again, this is money. And I did that because they gave us how much in money that those added up to. Alright, so that's $11.25. Alright, so those are my 2 equations. If you can get that far, usually people get that far, they don't have a problem solving it. It's getting to that point that really is a challenge for some people. So let's solve these by elimination. Notice I don't have the same number in front of the coefficients, so I'm going to have to multiply 1 or 2 of these by something. And it looks like if I multiply the top one by 3, that would make this into a 6. And if I multiply the bottom one by 2, that would make this into a 6. So that's what I'm going to do. I'm going to change both of these equations so that I can eliminate the variable. So I distribute the 3, I get 6x plus 24y equals 33. I distribute the 2, I get 6x plus 10y equals 2250. Okay, and now I'm ready to eliminate. Okay, now I can just subtract these 2 equations. 6x minus 6x, that gives me 0x. 24y minus 10y, well, that gives me 14y. And 33 minus 2250, well, what does that give me? That gives me 1050. Okay, so now what if I divide? Well, let's write down my equation first. That's 14y equals 1050. What if I divide both of these by 14 so I can solve for y? And let's get my calculator out here. Move that over out of the way. Let's see, we got 1050. And I'm going to divide by 14. Oh, 75 cents. Whoops. 75 cents. Okay, so each notebook cost 75 cents. Alright, and to figure out the cost of each pencil, well, we're going to take one of the original equations. I'm going to go over here to one of the original equations. I'll take this top one, and I'm going to plug in 75 cents for y. Now I just need to do the math. So x, 2x, and let's see, I need 8 times 75 cents. That's going to give me $6. Okay, so that is a 6. I take away 6 on both sides. 2x equals 5. And I need a little more space here. I'm going to divide by 2, divide by 2. That means each, what is that? Each box of pencils is going to be 250. So I can come up here and answer my question, 250. Alright. So there you have it. Is that the only way you could do that problem? Absolutely not. You could, you would have to use the same equations, but you could multiply top and bottom by different numbers. You could have multiplied the top by 5 and the bottom by 8. You could multiply the top by -3, the bottom by -2. Those will all get you to equations where you can do elimination method. Alright, but you will get the same answers as far as the cost of the pencils and cost of the notebook. Alright, so there you have it, guys. Hopefully those went well. Those are definitely a step up. So look over them again. Enjoy your night, and thanks for watching.